Okay, in this video, which is part 2 of our series of videos in finding inverse Laplace transforms, we're going to look at how to find the Laplace transforms of these two functions here. So we're going to start off with the first one. Now, in the first video, which is the part 1, we mentioned that the first thing that we always want to do when we have a problem like this one, for which we want to find the Laplace transform, is to factorize the denominator. So here we have got s squared minus 4s plus 13. Now you're going to find that if you try to factorize this, actually it is not going to yield any fruitful results. Just to be sure, so what we do here, if you try to look for factors and you can't find, you want to work your b squared minus 4ac, which is the discriminant, and if that one is negative, then you know that the quadratic cannot be factorized. So this is going to be 16 minus 4 times 13 is 52. So this is going to be 52 minus 16 is going to be negative 36. So since this is less than 0, this is telling us that the quadratic is not factorable. Okay. By the way, if the discriminant is equal to a square number, then the quadratic expression is discriminant square numbers like 0, 1, 4, 9, 16, etc., or rational expressions of these, then your quadratic is factorable. So this time the denominator is not factorable. However, that doesn't mean that we cannot find the Laplace transform. So if just look at the Laplace transform table again. So for this one, what we're going to want to do is to express this like these two expressions right at the bottom here. So if you want to express them like these two, you can see that this expression and this expression are quadratics where the square has been completed. So the idea is to complete the square and write the expression either like this one or like that one, and sometime it works out that you're going to come up with both forms. So here the thing we're going to do is we're going to start by completing the square in the denominator. Okay, so we're going to go through this pretty slowly so that everyone can follow what we are doing. So 4s plus 13. Now, to complete the square in something like this, what we need to do is to write the first two terms in this form as something squared. Now, that something squared always has the same sign as this one inside here. So we're going to have a minus. The first term is always going to be s. The second term is then going to be half of this. So in this case, it's going to be minus 2. Then what I'm going to do is I'm going to drop down this plus 13. Okay. Then the last bit of this is we always subtract the square of this. So in this case, 2 squared is 4. So we're going to take away 4. So the expression now looks a bit like this. So we have got s minus 2 all squared plus 13 minus 4 is plus 9. And then of course that we can write as 2s plus 1 s minus 2 squared plus 3 squared. Now if we just go back to our table, so you can see what we have now is looking a bit like this one here, because we have got s in the numerator. However, for this one, the term in the numerator is identical to the term inside the brackets here. So that is the next thing we're going to try to do in our expression algebraically. So what we're going to do, we have got 2 here, we have got s here plus 1. Then in the denominator we've got s minus 2. So from what we just looked at, we're going to need s minus 2 here. So since there is no minus 2, we slot it in. So we're going to put minus 2 plus 2. Minus 2 plus 2 is 0, of course. And then so in the next step, what we're going to do is we are going to factor this s minus 2. Then what's going to remain is going to be this times this, which is plus 4. And then the plus 1 is the same as this one. Okay, minus 2 squared plus 3 squared. Then this is now 2 into s minus 2 plus 5 s minus 2 squared plus 3 squared. And then at this point we are going to use the distributive property of division. Going to write this as 2 fractions. So this is going to be stand alone, and then the other fraction is going to be 5 all over the same thing. Now the first fraction, this one here, is now starting to look like the second expression here. So the numerator has got s minus a, denominator s minus a. The other fraction, there is no s in the numerator, so we need to make it look like that one. Notice that this one has got a b in the numerator. Okay, so if we go back here, this one is almost in the form that we need, because the only thing is this 2, which we can always factor outside the Laplace inverse Laplace transform operator. This one though, according to that table, we need a 3 in that denominator, in that numerator, because notice we have b squared here and b there. So in our example, b squared is 3 squared. So we need a 3 in the numerator. So I'm going to write 3 here. The 5, I am going to factor it out. So bring the 5 here. But if we write a 3 there, then we need to divide by 3 here as well. Okay. I think we're almost there now. We're now ready to take the inverse Laplace transform after these algebraic manipulations. So the inverse Laplace transform of f is going to be 2. So these 2, we factor it outside the inverse Laplace transform operator. S minus 2 here, s minus 2 squared plus 3 squared. So that's the first term. Then the second term is going to be 5/3 the inverse Laplace transform of 3 all over s minus 2 squared plus 3 squared. Then we are almost there now. Going back to our table again, so this term inside the squared bracket is a, and this term is b. So this one gives us a cosine, so that means we're going to get e to the 2t cosine 3t, then 5/3 e to the 2t sine 3t. So that is going to be our inverse Laplace transform. Of course, here we can factor out the e to the 2t, so it's going to be 2 cosine 3t plus 5/3 sine 3t, and that is going to be the inverse Laplace transform of that expression. Okay, at this point, so that was a bit lengthy, but hopefully you understood all the steps. We're going to give you an opportunity to have a go at this b. You're going to find that just have a go at this. You'll want to pause the video, work through it, and then when you continue the video, then you can compare with our solution. All right, we're now going to scroll down to our solution for this example here. We are hopeful that these are useful for you. Please do not forget to subscribe to our channel, and if you've got any questions on the steps we do, any comments, you can post them in the comments section. Please do like the video and share accordingly. All right, so in part 2, or in part B, so in completing the square, what's going to happen is since we've got a plus here, that's going to be plus. So this first term is always s. The second term we said is going to be half of this term. So in this case, that's going to be plus 1. Then we drop down the plus 5 as it was there, and then we always subtract the square of this term. So in this case, it's going to be minus 1. So then the numerator is still s minus 3. Denominator simplifies now to s plus 1 squared plus 4. This 4 is the same as 2 squared, so we can write this as 2 squared. Then again, so comparing with our table, we want the s term in the numerator to match with the term in the denominator. Okay, so we want the s term in the numerator to compare with the denominator. So here we have got s minus a there. So we're going to go back to this. We've got s plus 1, so we need s plus 1 there. So that's exactly what we're going to do. We don't have s plus 1 right now, but we can insert plus 1 here. Insert plus 1, then of course we need minus 1. Then all we're going to do is we're going to keep this inside the brackets and then not disturb it. Then the minus 3 that was there, we bring it back. Okay, the denominator still s plus 1 squared plus 2 squared. Okay, then in the numerator that term we're not going to disturb. This one becomes minus 4 s plus 1 all squared plus 2 squared, and then at this point we split this into two fractions, so this one is going to have a fraction of its own. So the first one, s plus 1 all divided by s plus 1 all squared plus 2 squared, then minus 4 over s plus 1 squared plus 2 squared. And then the first one is now perfectly in the required form. The second one, maybe we need to manipulate it algebraically, again checking our table. So the second one is the one with constant in the numerator. So if you look at this, we need b there corresponding to that b squared. So if we go back, our b squared is 2 squared, so we need a 2 here. We already have a 4, so that means all we need to do is to factor out one factor of 2. So if we put 2 outside here, then 1, 2 remains inside there. And then this is now in the required form. So then the inverse Laplace transform of f of s is going to be equal to the inverse Laplace transform of s plus 1 divided by this, then minus 2 times the inverse Laplace transform 2 over s plus 1 squared plus 2 squared. So comparing again with this, our a is negative 1 in our case, and our b is 2. So what's going to happen is the first term is going to be e to the minus t cosine 2t. Then the second term is going to be 2e to the minus t sine 2t. If we factor out the e, then this is what we're going to have, minus 2 sine 2t. All right, thank you for watching.